Cross-site scripting, or XSS, is one of the most common vulnerabilities of web applications. It's caused by improper input and output validation. So generally it happens by including malicious client-side scripts into web pages. And when a victim visits the page or clicks a code-injected link, then the malicious script code is executed. And at this point, the victim's browser has no way to determine whether the script is trusted or not. So it'll just execute the script. And by the execution of the script, it can access cookies or other sensitive information retained by the browser. Such a script can even rewrite the entire content of the HTML document. Although XSS attacks are possible in VBScript, ActiveX, Flash, and even CSS, the most used language, of course, is JavaScript. So executing untrusted JavaScript code in browsers can have devastating consequences. Anyway, we can divide XSS attacks into 3 types: reflected, stored, and DOM-based XSS. So in the next few lessons, we're going to cover XSS flaws in detail. So this type of XSS vulnerabilities occur when the malicious input in an HTTP request is immediately returned to the victim's browser in an HTTP response. So the malicious input data is not stored on the backend. So that's why we call it reflected. What the attacker enters is reflected to the victim quickly. Now, it's also known as non-persistent or first order or type 1 XSS. Reflected XSS vulnerabilities require the malicious script to be embedded into a URL. So, as a pen tester, we should try to find a way to entice the victim user to click the link containing the malicious script. Now, in order to be successful, the user needs to click on the infected link. But before that, we need to use whatever social engineering technique we need to deliver the infected link to the potential victims. So open Kali and log into BWAP, just like we always do. Now, as you can see, there are many examples of XSS vulnerabilities in BWAP, and I'm going to exploit some of them, not all. So let's first choose the XSS reflected get. And it's nothing but this sample page. But what you type in the fields will be reflected to the page. And then the values will transmit over the URL. And view the page source. And here are the values I typed. So this is a suspicious form. Okay, so now let's have a look at the code. Now, here at the beginning, there is a function named XSS, and it calls XSS check3 and check4 functions according to the security level. So scroll down a little bit, and it grabs the values in the form, then it uses them in the XSS function. All right, so if the level is low, the values will be printed to the screen directly. If not, XSS check3 and check4 functions will be executed for medium and a high level. And this function is in this file. We'll scroll down, and here are the functions. So check4 uses add slashes function to prevent these characters. And check3 uses HTML special chars function with encoding. So go back to Firefox, and I'm going to paste HTML1H1 tag in here, and it's executed. So view the source, and here's the problem. So the input is not sanitized at the back end and added the source of the page. So let's look to see, and there's no difference between this tag and any other HTML tag on the page. No encoding or anything else. and this tag is reflected with the page to us again. So now I'm going to paste another HTML tag. And it's here in the source. Okay, so this time I'm going to add this tiny JavaScript code, and it's also executed. So view the source, and here are the script tags that we sent. And now I'm going to change this JavaScript code a little bit. Then fill in the form and go. And in the message box, we see the cookies and the session ID as well. So how do we benefit by executing JavaScript in the browser? So JavaScript provides us the power to do many things browser side, but we do have to use the browser. So in order to hack, we need to execute JavaScript in someone else's browser. So copy that URL and open another tab and paste it and go. So you can see JavaScript payload in the URL is executed as soon as I open the page. Or, in our scenario, clicking a link. So we need to deceive the user to click a link, right? But alerting the session ID is not a good way. So you can use this code. It will send base64 encoded user's cookie to my application. You can download and host it on your Kali or your host if you like. It's a simple Bootstrap 4 app. So paste this payload in here. Open the Web Developer tool, then go. And what do you see? The code is sent to the server, and nothing happens at the back end. But then the JavaScript code is reflected to the page, and then this JavaScript code executes and sends the encoded cookie value to my grab page. So view source. And our payload is perfectly displayed here. So now go to the Cookie Stealer app, refresh the page, and we have an incoming session. So click to log in. Username is awapt and password is 12345. And the cookie with the session ID is here. Now from the More button, you can view details about incoming requests. You can check to see if the session is live or not. Return to sessions. Also, you can view the main page on BWAP. And as you can see, here's our current user. Okay, then go back to Kali again. And I validated the XSS vulnerability. So now copy this URL, then log out. Open BWAP with just as another user. So I'll log into it as BWAP user 1. And let's say somehow I've sent the link to this user and the user clicks on it. So that means I'm just going to paste it here and hit enter. View source. The value in the URL is lying in the source. Then go to Cookie Stealer app, refresh the page, and here is a new user's cookie. Now go to session, and it is BWAP user 1 session. So we stole the session ID value of the user and we'll use it to authenticate ourselves. Good. So let's have a look at some other examples.